Hey there guys. Hope everyone's well. Welcome to O-Level Physics. This is Lesson 7, Pressure in Solids, Liquids and Gases. Pressure is normal force per unit area, P equals F, all over A, measured in pascals, where 1 PA equals 1 N over M squared. The same force produces greater pressure on a smaller area. A 600 N person standing on total sole area 0.040 m squared exerts 15,000 pascals. Sharp knives and needles use small contact areas for high pressure, while snowshoes spread weight over a larger area. In a liquid at rest, pressure acts in all directions and increases with depth. For density ρ, depth h, and gravitational field strength g, pressure increase is P equals RHOGH. Water at 5.0 m depth with RHO equals 1000 kg m cubed and G equals 10 N over kilograms produces gauge pressure 50,000 pascals. Container shape does not alter pressure at the same depth in the same liquid. The relation follows from the weight of a liquid column. A column of area A and height h has volume R, mass ρr, and weight ρarg. Dividing weight by area gives ρgh. This explains why pressure depends on density and depth but not on cross-sectional area. Total pressure may include atmospheric pressure in addition to liquid gauge pressure. Pressure differences create forces. A dam is thicker near its base because water pressure and resulting force are greater deeper down. Hydraulic systems transmit applied pressure through an enclosed liquid. If pressure is equal, F1, all over a 1 equals F2, all over a 2, so a small input force on a small piston can produce a larger output force on a large piston, though the larger piston moves a shorter distance. Atmospheric pressure comes from collisions of air particles and the weight of air above us. It decreases with altitude because less air lies overhead and density is lower. A barometer measures atmospheric pressure. Drinking through a straw works because reducing pressure in the mouth allows greater atmospheric pressure on the drink surface to push liquid upward. Suction does not pull liquid without a pressure difference. Gas pressure is caused by particles colliding with container walls and changing momentum. At constant temperature for a fixed mass of gas, pressure and volume obey P1V1 equals P2V2. Compressing a gas makes wall collisions more frequent, increasing pressure. For example, reducing 240 cm cubed at 100 kPa to 120 cm cubed gives 200 kPa. State the fixed temperature condition whenever using Boyle's law. Convert area to m squared, identify whether gauge or total pressure is required, and use P equals F, all over A or P equals RHOGH. For gases, state constant temperature and keep pressure and volume units consistent. A force of 150 N acts on a piston of area 0.005 m squared. Pressure equals 30,000 par. On a 0.020 m squared output piston, this gives F equals par equals 600 N. Do not confuse pressure with force. Use cm squared as though it were m squared. Say liquid pressure depends on container shape, or apply PV equals constant without constant temperature. Practice. A 900 N force acts over 0.030 m squared. Find pressure. Answer: P equals 900 all over 0.030 equals 30,000 pascals. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. Practice. A gas occupies 300 cm cubed at 120 kPa. Find pressure at 200 cm cubed at constant temperature. Answer: P2 equals 120 x 300 all over 200 equals 180 kPa. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. We'll leave it there for pressure in solids, liquids and gases. When we come back, its particle model and thermal properties. Thanks for watching. See you then.